I'll record right here. Continue. And here. All right, welcome everyone. We are going to be talking about transformations of quadratic functions. Transformations just means movement, okay? How the quadratics move. So let me go ahead here and grab my notes and we'll be looking at this. All right, let's get going. So we will apply translations, dilations, and reflections to quadratic functions. So these are three of the transformations that we will be discussing today. Right? Okay. So here we go with this. Our first transformation. Here we have a movement of a geometric figure so basically, let's say that I've got like, I don't know, a little triangle here, right? And if I'm slide it to the right, my new triangle is going to be right over here, like so, right? That's a generic movement, okay? A transformation, okay? And this one, what is not a movement is if I have, let's see, a transformation, I guess if it just stays the same, right? If I have my original triangles right here and guess what? It didn't move at all. It's right there, right on top of it. Well, that's not a transformation, right? All right. A translation is a transformation, a very type of movement, where a figure is slid from one position to another without being turned. Okay, so this right here, that is a translation. It's like a slide, right? It just slid to the right, okay? My counter example would be something like this, where I start off with perhaps a triangle, right? And then I end up with this. Okay, see how that was kind of turned, right? And that is our counter example. That's not a translation. Okay, today we're going to be talking about two different types of translations. We're going to be talking about a vertical translation, and that's where we go either up or down. And then, of course, we're going to be talking about horizontal translations, and that's where we go from left to right. Okay. Now, dilation. Has anybody ever heard of the word dilation before? When? In 8th period math. Okay, great. Anybody ever heard about it? Like if you go to the doctor, the eye doctor, and they dilate your eyes, what happens to your pupil? It gets big, right? Does it change shape or anything like that? No, it doesn't. It's basically goes from being like a circle like this, right? Let's see if I can make it look like a circle. So a circle like that, and then it makes it bigger because they want to go inside and take a look at it, right? And of course, if you step out into the sun and your pupil actually like constricts and becomes really, really small, right? So that's dilation. It's essentially, it's a transformation that alters the size of a figure, but not its shape. So it's not like, you know, the sun comes out and your eyes are like triangles now or something like that. Okay. So here we start off with, say we have a circle, and then you end up with like a triangle. That's not a dilation. Okay. And of course, this is not, these are counter examples. And I'm going to go ahead here and put that. Okay. So reflection. Okay. Somebody told me this was a balloon. This is actually supposed to be a mirror. Okay. And if I had my X and Y coordinate, I'm going to put my X axis right here, X axis. And let's say that I had a parabola, touched like that. And it was reflecting in the mirror. It would kind of look like this, right? Y'all see that okay? So the reflection would be like that. So a reflection is a transformation where a figure, line, or curve is flipped. Across a line. Okay. And so my example here would be, let's say that we start off with something that looks like, I don't know, I'm just going to put like, I'm thinking kind of like a clock is what I'm thinking, like that. And then once it moves, it kind of goes like, oh God, I don't want to do it. I guess we could just make it slide like this. That's not a reflection, right? That's actually a series of two movements going to the right and then going down, right? Okay. And then finally, this one's super duper important. So I'll put it in red. Vertex form. This is a quadratic function in the form of f of x, fancy way of saying y, is equal to a parenthesis x minus h to the power of 2 plus k. Okay? Each one of these things is going to mean something. So the very first thing I want to look at is a. And the absolute value of a is going to refer to dilation. Okay? H right here is for horizontal translation. So A is for dilation, A is for horizontal translation. And that's where you move like that, either right or left. And then K, which is usually in the position of C, right, which is for like usually your y-intercept, which makes sense because it's the y-axis goes up and down. So K is all about your vertical translation. Okay. And I think that'll be enough to get us through today. So let's go ahead and let's look at example 1A, okay? I'm going to go ahead here and I'm going to do a little table. I'm going to start off with X right here. You will need your calculator, boys and girls, just saying. Does anybody, we're going to describe how this graph of this equation right here, this quadratic, is related to this quadratic. Now there is a special name for this quadratic. If you know it, you can put it in the chat or you can blurt it out right now. It has a very special name and you need to know it because on your exam, it's not going to give you the equation. They're just going to give you the name of the equation. So does anybody know what this is actually called? Okay. Let me talk to Anayan. Go ahead and share with me and let me know if you need a hint. You need a hint? Starts with a P. You don't know? Can anybody help her out? Ooh, all right, here we go. Parent quadratic, okay? This is the parent quadratic. So what they're going to say on your test, they're going to say, like, describe how the graph of this is related to your parent quadratic, to the parent function, okay? So it could say the parent quadratic, it could say the parent function. So make sure you know that because they won't give it to you. So I'm going to go ahead here and I'm just going to put in all these values. Now, just because I've done this a time or two, I kind of already know that we're going to have to adjust the y-axis, guys. We're going to have to make it go up by 5. And so this is going to be like 5 and 10 and 15 and 20, okay? So I'm just going to kind of put that in. And I'm feeling a little lazy. I'm going to go to y equals. And I'm going to type in my equation. I'm going to first type in the parent quadratic, x squared. Everybody knows x is right next to alpha, right? Got the x squared. And I'm going to go to table, which is in blue. So I want to hit the blue button first. Second, graph. And I'm going to start off at -4. So I'm going to put in all these values. I got -4, -3, -2, -1, 0, 1, 2, 3, and 4. And we're just squaring it. So it's like 16, 9, 4, 1, 0, 1, 1. Nope, not 2 ones in a row. Hello. 1, 1. It's just 1, 4. And then, you know, with symmetry, can you guess what 3 is going to be? 9. Good. See how you got like 0 and then you got the 1, 1? And you got the 4, 4. Now you're going to have the 9, 9 right there. And you're going to have 16 right there. Yeah. So let me just double check. Sure enough, we got 9 and we have 16. So yeah. Okay, that's called symmetry. So now we're going to go ahead and we're going to compare it to our new equation of x squared plus 10. So I'm going to draw in the parent quadratic first. I'm going to go ahead and plot these points. I got -4 and 16. So that's about right there, right? And I got -3 and 9. And I have -2 and 4. And -1 and 1. And then 0, 0. I know this is my lowest point, so that must be my vertex. And I'm going to go ahead and I'm going to use symmetry to help me plot my other points. And you know, graphs are not exact, and that can be good or bad. But essentially, we want to try and make it curved and something like that. That's our parent quadratic. Okay? So now let's get started with the plus 10. I could put it in my calculator. Put it right here. X to the second power plus 10. And I'm going to look at my table, second graph. So let's go ahead and let's put in some values from the table here. I'm looking at -4. Let me go up. I got 26. I got 19. Oh, it's just like I'm adding 10, right? So I can say 14. 10 plus 1 is 11. 10 plus 0 is 10. 11. 10 plus 14 is 4. 10 plus 4 is 14. 19 and 26. Y'all see where I'm getting the numbers from? Makes sense? All right. So now we're going to plot those points. 26, that's like too big. But we can do -3, and then we're up at 19. So that's like about here, more or less. -2 with 14, about right here. And -1 at 11. And 0 at 10. Do you see kind of what's happening here? What's happening? It just slid up, right? What's going to be our fancy way of saying slide? Translate. And what kind of translation is it? Horizontal or vertical? It is vertical, y'all. Okay? Because basically this point right here, that's going up by 10. This is going up by 10. Each one of these little points is going up by 10, right? Plus 10. All right. So let's talk about why that makes sense. I'm going to write the formal way we say this because it says describe the graph and how it's related. Okay. So essentially there is a vertical translation, or vertically translated, vertical translate, vertical translation. Let's do translation. I have to think about how I want to say this. Translation up by 10 units. Okay, sounds good. Now, when we look at this 10 and you look at this equation right here, what variable, you can put it in the chat, what variable is 10 replacing? The A, the H, or the K? I'll look for it in the chat. Just type it in. It's like one letter and then you hit enter. Okay, see this equation right here? See this equation right here? See how we have 10? What variable is 10 replacing? A, H, or K? Yeah. And right now I'm looking at my screen. It looks like everybody's just kind of being short with me. Except for Michaela. All right. All right. So, because it looks like K, 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 K. Yeah, it is. It's totally K. If it was H, it would be inside the parentheses, right? So this is all about K, and K is about vertical translation up and down. And it makes sense that since K is positive, that it's probably going to go up by 10, right? Make sense? Logical? Okay. So if that is logical, let's take a look at this right here. And I would like for you to make a prediction about what's going to happen with this one, okay? And you can put it in the chat. I'm going to go ahead and draw the parent quadratic while y'all do that. I'm just going to go ahead and put it in. I got 1 and 1, 4 and 4, 9 and 9, and 16 and 16. I got something like this. I'm drawing in my parent. Something like that. Yeah, because I'm just doing, remember that this increases by 5s? Yeah, so that's the deal with that one, okay? All right, so I got a couple. It's going to slide down. It's going to go down by 8. It's going to be a frown. Okay, let's see what happens. So let's go ahead and I'm just going to cheat here, and I'm going to go to y equals. And it's going to be the exact same line, but on -8 on the y-axis. Okay. So I'm going to just replace the plus 10. I'm going to hit -8 and then delete just to delete the one thing. And I'm going to look at my table. I find the tables are the best for getting points because graph, your eyeballs can lie to you really easy. So I'm going to go ahead, look here. I got -4 and I got 8. So let me go ahead and do that. Go ahead and put it on color. So I got -4 and 8. So that's like about right here, right? And then I've got -3 and 1. Everybody sees where I'm pulling these numbers from, -3 and 1. So -3 and like 1. And does anybody see anything yet? No? Okay. And then I got -2 and -4. Oh, wait, did I do this right? Yeah, I did. I just want to double check. I would hate to get through this and like did it wrong. -2 and -4. So -2 and -4, that's going to be about right here, right? And then I've got -1 and -7. So that's about like right here. And then I'm like 0, -8. And then I can kind of use symmetry to like do the rest. So when I connect my dots, those of you who said that it's going to slide down, translate down, that's exactly what it looks like it happened, right? And those of you who said that it hits the new right here at 0, -8, you're absolutely right, right? And that makes sense when you think about quadratic with the value of c determining your y-intercept, right? It also makes sense when we think about k, and you have a -8. And so the formal way of saying it is we're going to say that this was a vertical translation. Okay, I'll start higher. Vertical translation down by 8 units is how we would say that. Easy enough? Say it again. It would be X and not the value of Y2?
No, it would be X matching up with Y2 on the calculator.
Oh, yes, because keep in mind in the calculator, she says, is it going to be X matching with the Y2? Yeah, because remember that the equation that we are now plotting is Y2. And so I want to use those values. This is for my parent. Got it? Okay, great. All right, so that's all about K. That's basically the two cases for K. Let's go ahead and am I able to move down? Is that okay? Okay. Let's go ahead and let's talk about this right here. Okay, I'm going to go ahead and rewrite the equation on top. And I have y is equal to, it was f of x, but they're the same thing. X minus h to the second power plus k. And in the chat, I want you to go ahead and share with me. When I look at this equation right here, what do we now have a value for? Which variable are we looking into right now? A, H, or K? Give you a couple seconds. Yay, yay, yay. Good job, good job. Yes, excellent. So if we're talking about, and I know some of y'all are still typing it in. It's okay. If we're talking about H right here, right? Go ahead and put in your prediction. What's going to happen? This is horizontal, right? So we know it's going to be a horizontal translation. But I want to know in which direction and by how many units. So let's make a prediction. Thank you, Michaela, for your feedback. Oh, that's interesting. Oh, okay, you changed your mind. Okay. So a lot of you said to the right by 1, right? So let's see. I'm going to go ahead here and I'm going to plot the parent quadratic. Again, we're going by 5s. 5, 10, 20, nope, 15, hello, and 20. And I'm just going to go starting off at 0, 0. My parent always starts off at the origin. And then we got 1, 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And that looks like 25, but it's actually 15, y'all. Okay. And then symmetry will allow me to do this. And moving up.
Wait, why'd you put 25?
Okay, because that was supposed to be a formal 1, but you're right. It totally looks like a 25, and I'm going to change it right now. Yay? All right, so let me go ahead and draw my parabola. Not a pretty word to say. It just kind of ends like blah. But I do have a lot of people who always want to say parabola. It's not that. It's parabola.
Sounds better.
It sounds better?
Yeah.
We should change it. We should just make it parabola. Why not? Okay.
What even is it?
Oh, that does sound okay. Anyway, well, let's move on. So, ladies and gentlemen, I'm going to go ahead in here and I'm going to put in the whole, I'm just going to clear that whole thing out. Clear, 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 right? And then I'm going to put in our new one, parenthesis, x plus 1, close parenthesis, to the power of 2, right? And I know you're following along and not wishing you were somewhere else. All right. So we're going to go to our table, second graph. It was plus 1, but it's inside of the parentheses, just like we have right here, right? Yes. But you got to put the parentheses around it or it's not going to work. Okay. And then second graph. And I totally recommend that you're doing this along with me because guaranteed I can do it and then you try and do it and does it come up the same? No, right? Okay. So try and do it with me. And let's go. -4, 9. Okay, so let's go ahead. I'm going to pick a bold color. Let's go with pink. -4 and 9, that's about here. I've got -3 and 4. Hopefully you see where I'm pulling this from, right? -2 and 1. And -1, 0. And then 1, 4, and 9. So I got a little symmetry going on right here. And pulled this one over here, right? So what do you think? What do you think happened? To those of you who said that it shifted to the right, what happened? It shifted to the left. Now take a real good look at this equation and tell me, why do you think it shifted to the left by 1? Because that totally shifted to the left. And I'm going to write that in our formal right here. Horizontal translation to the left by 1 unit. We're going to pretend that says unit. Umit.
Well, why didn't it go to the right since it's positive?
Exactly. Let's, what? Say it again?
Why didn't it go to the right since it's positive 1?
Let's look at this equation. Nobody has any insight online. So what do you notice about this equation versus K and H? What's the difference between H and K?
Positive and negative.
Uh-huh. And so if this part right here, let me set up my skeleton, H minus, right? And then I got K, and I got to the power of 2. What would have to be the value of K for it to end up equaling X plus 1? Incorrect. Because if I just had 1, if I just had positive 1 in there, right? Then that doesn't match, right? What needs to be in front of that 1? A negative, right? So ladies and gentlemen, that should be -1. Technically, H should be -1. Do you see that? That 1 sign makes a difference?
Wouldn't it just be 1 big plus sign?
Because it's negative times a negative is a positive. So absolutely, this ends up equaling that. That's what we want, right? So H actually ends up being -1. So what I want you to remember with the parenthesis, okay, is that if it's in the parenthesis, that I think about it like this. I'm going to go ahead and make an O because it is opposite of what I think it should go. Opposite of the way. Because, you know, the positive numbers live over here, right? Negative numbers live over here. It's got a positive 1, but it's going the opposite way I think it should go, right? So it's -1. So if I look at this right here, I got X minus 4 to the power of 2. Which way do you think this is going to go? Remember, it's opposite. So because negative numbers live here, positive numbers live here, and it's the opposite of what we think, it should go to the right. So let's double check. I'm going to write it down just in case, because I know I'm right. Horizontal translation to the right by how many units? 4 units. And I'm going to verify this, okay? I'll give you a little time to write while I draw my little parent quadratic. So drawing the parent, got my 5, got my 10, got my 15. Okay, so we got 1, 1. 2 times 2 is 4, 3 times 3 is 9, and 16. A little symmetry going on right here, and right here, and right there. We're going to draw that parabola. Okay, so I'm going to put it in, and I'm just going to type right over it, -4. That's not a 4. 4. Step away, make sure it looks the way I want it to look. It does, and I'm going to hit graph. Everybody have something like what I have? So there's your parent quadratic because it's the one with the vertex at the origin. And sure enough, it went to the right by 4. So the graph is good to look at just to kind of give you an idea like, yeah, this is kind of what happened. Is it good to know like exactly how many units? It's kind of hard to count, right? But it does give you an idea that we went to the right. Any questions on this? Okay, so for this one, if I sketch it really quick, we're just going to shift this dot right here, 1, 2, 3, 4 to the right. Shift this one to the right by 4, 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. And my vertex, 1, 2, 3, and 4. And there's my new partial parabola. Okay. Feel okay about the K's? But this is the H's, right? So just remember opposite, okay? We've talked about K's, we've talked about H's, and now we're gonna move them together. Anybody need more time? Okay, let's go ahead and let's look at this. Y'all are unusually quiet. So I want y'all to make some predictions. Go ahead and put it in the chat. And I want you to predict what kind of movements are we gonna go, or are we gonna have here, okay? What kind of movements are we gonna have here? Let me see what y'all put. So basically we're looking at two things, right? We got H minus, that's the horizontal, right? And then you got the plus K. So the plus one right here for the K, when it's plus one, we know that that is going to go up by 1 unit, okay? And this part right here that says H, where we're talking about H, so this is X plus 1, okay? It's the opposite of what we think it would go, so it's going to go to the left. And again, the unit inside of there is 1, so we're going to go to the left by 1. So I'm going to put by 1, and I'm going to put by 1. Okay? So if we start off with our parent quadratic, and right here I've got 5, 10, 15, 20. Is it getting easier to draw the parent, or y'all just putting it together? Okay, so I got 1 times 1, that's 1. 2 times 2 is 4. 3 times 3 is 9. And then 4 times 4 is 16. So that goes up there. Go ahead and draw this like that. And we're going to look at our movements. So I always like to start off with the vertex, okay? I'm going to go up by 1. Now, keep in mind, is this going up by 1? No, that's going up by 5, right? So I'm going to go up just a hair, and then to the left by 1. That's a full one right there. Okay. So if I'm at this point, I'm going to go up by 1 and to the left by a whole 1. And this is going to go up by 1 and to the left by like right here, right? Something like that. And up just a hair. Wait, did I do that last one right?
Wait, so wouldn't it be 8?
Hold on. This is where it gets like my drawing's crap. Okay, sorry. Did I say that on recording? Okay. So I'm starting here at my vertex. You know what would be an easier way for me to just put it in here and look at some actual points and look at the table? So I'm going to go ahead and do that. Plus 1. And then go to the right, plus 1. I'm going to look at my table. Second graph. And so I've got -4 is 10. So let me see. -4 and then 10. This will probably be easier. -3 and 5. -3 and 5. And then we have -2 and 2. -2 and 2-ish. Okay. -1 and 1. Hey, I think I did that one okay. And then 0 and 2. So 0 and 2 is actually like, yeah, slightly higher. So that was our original one, right? And then I'm going to go ahead and then just use symmetry, right? So this right here is going to go with this one. And this one's going to go with this one. And then I've got 4. Scroll down. 26. And that's way too high. So I'm going to go ahead here and just draw what I've got. And this green dot, that's the original vertex. Okay.
So you went to 5 instead of 9.
What are you talking about? Which one? Which point is in question?
The green.
This one?
No, the one to the left.
This one? 1 and 5. So this is, see how this is 1, 2, 3. So we go to the right by 1 because that's your X value, right? And then you go up by 5. So this dot, what happened here is that we went to the left. So this, what happened here is this. What had happened is that we went to the left here by 1, right? And then we went up by 1. But that one's like way smaller. Do you see it? Because this is up by 5. Okay. All right. And so, yeah. Any other questions? It's always kind of good to double check your stuff. And that kind of looks like what we got, right? So we're good. Yes. Any questions on that one? I want y'all to go ahead and do 3B on your own. And then we'll look at it together. I don't know where you get 1 from. All right, welcome back. There are 2 things that are going on out here, okay? The first one is the -2. You got x -2, right? That's one movement. And the other is the +6, okay? So let's talk about the whole x -2 thing. That is inside the parentheses, so we make an O for opposite. So x -2 squared essentially is going to refer to, instead of going to the left where the negative numbers live, we're going to go to the right. So this is going to go to the right by 2 units, guys. Okay. Now this one is opposite, but this one is not. Okay. So this is your H, because remember the formula kind of looks like that, right? You got H. H is for horizontal. K over here, though, is straightforward. It's basically your vertical up or down. And because it's +6, that's going to be up. +6 means that it's up by 6 units. Questions? Okay. So when we write that formally, we would say there are 2 transformations. A translation what kind of translation? Let's talk about I need to add a word in there. We can say a horizontal. Sorry, I didn't pick your word. A horizontal translation to the right by 2 units. Most of the time, I have seen this as a multiple choice type of question. And then the second part would be, and a vertical translation up by 6 units. Now, my original parent vertex is right here, right? And I'm just going to pick, I'm going to make a lot less points. So I'm going to pick that point where we have like 5 and then we have 10, right? And then I've got that point -2 up. Yeah, let's do the -2, 4. So -2, 4 and +2, 4. Wait. And then what we're going to do is we're going to go to the right by 2 units. So to the right by 2 units, that's this way. And then up by 6. So that's going to be up to the 5 and then probably a little bit further, right? So our new vertex is going to be located right here, right? And again, I could do that with these others where I go to the left by 2 and then up by, what was it, 6? So it's probably going to be something like this. So my new one is going to be right here. And due to symmetry, I can kind of put it up here. And we're looking at something like that, right? This is my new quadratic. And this is my parent quadratic. And I'm going to double check that. And I end up with x -2 and +6 graph. And we got something like that. Okay. Please note that it's slightly off because the graph in the calculator is not incrementing by 5 units on the y-axis and mine is. So that does kind of make it look a little different. Any questions? Have a beautiful day.